Just before Christmas in 2011, I was fortunate enough to meet with George Hamstra of NetGain Motors. George took me to the Warfield plant in northern Illinois where his NetGain motors are manufactured. George explained how his motors are made and pointed out some of the different features that make NetGain such a great product. So thanks to both Warfield and NetGain, and have a listen.
Okay, Warp 9 cases. And we can tell these are Warp 9 cases in a couple of ways, Michael. Let me show you. One of the ways, we have the 3 timing holes. So this is going to be the commutator end. We've got the 3 timing holes set all the way around it. We have the countersunk field shoe holes. And most noticeable thing from externally is the 1/2-inch terminal studs instead of the 3/8-inch terminal studs. These cases have all been flooded, so you can take a look inside and you can see they're all covered with varnish on the inside, and I'll show you the step where they do that. What we have sitting up here are field coils and interpoles that are going to go into the 8911 motors, the high voltage 9-inch motors. See if I'm right, 8911. Yeah. So these are the fields and these are the interpoles. And those will go into an 11-inch case that'll have a 9-inch armature. Again, pretty easy to tell by the countersunk field bolts and the 1/2-inch terminal studs. These have all been flooded already. And here's where they do the flooding. They'll actually bring one of those cases over here with the fields in it, set it on here, turn this on, and completely fill it up to the top. Let the bubbles rise out of it, and then they'll bake it in the oven over here. I think they bake it at 350 to cure the varnish. Turns 180 degrees. Everything is taped up. Yeah, we don't do a lot of these. You can see the 219 coils.
The armature is really around the shelf over there.
Let me pull one of these out. This is the
Jack 501, Jack.
These are the field coils for an 8219 motor. Somewhere on here it's probably labeled.
It's inside.
Inside? Oh, there it is. I'm blocking it. Yeah. There it is. 8219
Oh, yeah.
are Warp 9. And again, the 1/2-inch terminal studs welded on. And that has to go on. These aren't our motors. These are explosion-proof motors. What makes these motors explosion-proof?
Oh my god. They've got about 5 hours. Everything makes it. The air gap, the pilot, you see the pilot here?
Yeah.
The pilot is like 3/4 inch deep. It's on a paper. What they do is they put these things together to test the UL or whatever to see if they're explosion-proof. They put them all together, and then they put gas into them. lighting.
because they're going to go into mining equipment.
Right.
Yeah.
All right.
Have any explosion, any sparks coming out of these things.
Yeah, so these are going into the mines. The motors that I showed you earlier, that I showed you the armatures for, those take people down to the mines, not inside the mines. When you go into mines, totally different.
Electrically, they're really overkill.
They're sealed.
There's not a lot of horsepower there. We're going to 10 horsepower here, but sealed. Everything's sealed. There's no holes that go through.
And these would be for accessing the brushes.
You got pipe threaded.
Yeah.
That go in there.
All very high quality steel.
Tolerances. Shafts come through. I mean, they're like 2 inches, and there's like 5 thousandths between the shaft and tolerances are all so tight. Mount that. Run the wires through.
Let's show what the thermistors look like before they're epoxied into place. And these are probably 120 or 150.
Probably 150.
150s. It's 150C.
Yeah, there's everything about them is closed down. Even the shoes and the shut.
Oh yeah.
They don't want smart coming
Anywhere.
anywhere. Yeah.
Now, are you going to plug these cases? We're in the process of converting a 1975 Brooklyn
Really?
with the gull-wing doors to all electric. These are the 2 motor cases for that vehicle. These are the first 2 11-inch motors to have the half-inch terminal studs on them. We did the half-inch terminal studs on the Warp 9 because it was the most popular first. And then these, we tested the half-inch terminal studs to make sure that they work. So these are the first 2 motors that have the half-inch terminal studs on them. One of these will be a straight Warp 11. The other one will be a trans Warp 11. And it doesn't make any difference which is which at this point. Here's the armature shaft for the trans Warp 11. And as I said, these are going into my personal car. So I had the cases powder coated, which we were thinking about offering as an option for people that want to have their cases powder coated.
It's kind of your signature red there, huh?
It's the signature red, yeah. And but you know, you can see the painted case, and the painted cases look nice. Right? I plan on showing this vehicle a lot, so I wanted to have the cases powder coated.
So the Brickland's your car?
The Bricklin is my car.
I got you,
Yeah.
okay.
Now, this is the Warp 11, but it's a modified Warp 11 shaft. And what I did on this shaft is we have a spline. You can see the typical trans Warp 11 has about a 5-inch spline. This one will have a 2-inch spline coming out of it, and it will match up to the other end of this motor, which also has a 2-inch spline. So the transwarp motor, this transwarp motor will be connected to the drive shaft, and the commutator end of this motor that used to have the .875 and been increased over to 1.125 now has a 1.375 32.2 involute spline shaft that will adapt to this. And so this, again, this Craig Dusing did the powder coating on these motors and on here. This will bolt on. I've already tailed 10,000 bolt on here. That studio one I showed you at the office will go into here and adapt to the drive shaft. And then this unit that Craig also powder coated is what will connect the 2 motors together.
Okay.
So it'll bolt to both motors. And then this is the adapter that will go on here and onto the other motor to connect the 2 motors together. So it'll be like one long shaft between them. And these are going to go into my Bricklin. We're looking at probably 240 volts of batteries, 200 amp hour lithium batteries, a 1400 amp controller. So we're looking at around between 500 and 600 horsepower and 1,000 foot-pounds
Wow.
of torque. Take a look at this. This is a high voltage 11. It's getting ready to force the field poles down. When you take a look at our Warp 9s and our other motors, you'll see there's about a half inch to 3/4 of an inch between the fields. When you take a look at the high voltage motor, and this is one of the things that makes this motor so difficult to make, is that it's a squeeze to get everything in here. And I don't know if I can, I'm going to have to wash my hands again, but as you can see, it's going to be really tight in here. This one is still using the GE style 3/8 inch terminal studs. The new ones are going to all 1/2 inch. And the difference is that these are modular connectors. So all they have to do is force everything in here and then bolt it together. When we go to the 1/2 inch terminal studs, it's a totally different situation. It's going to be a real difficult process to get these all to fit in here. Now, I'll show you the case. There's a couple of things in this case that are interesting. We have our, on the typical Warp 11, we'll have sets of 3 holes. Steve, you can come over here. We'll have sets of 3 bolts at 90 degrees to one another. On the high voltage 11, because we have interpoles, we've got 2 bolts every 45 degrees around the case. The other thing is this hole. There's a hole 180 degrees across from this one. One of these is for a thermistor that you can use to run a temperature gauge, and then the other hole is going to be for the temperature snap switch. That's 150 degrees centigrade.
So this is the 11 inch?
These are 11 high voltage motors. So they're the same diameter as the motors that I showed you over there, my motors, my personal motors. But these are, this is a limited run. We don't get a lot of calls for high voltage transwork motors. So, you know, he's only doing, looks like 2 of these at a time. Now over here we have, these are the end bells for my motors. So, again, the 1/2 inch terminal studs, these have been powder coated. And what you'll notice here is that we have 4 wires going to each brush. And that's because this looks like one brush, but it's actually 2 wafers, so that they can move independently. And then they have this patented red top that wood carbon is patented up on top to keep them in constant pressure with the commutator. So where we used to tell people that you know, you could probably get 170 volts for the motors, people that are using these new split wafer brushes, wood carbon split wafer brushes, with the new composition, the H49 composition, they're actually running these motors at 192 volts and no arcing. So this is what I'm using in my motor, and I'm planning on taking it up to 208.
Okay.
So we'll see how high they can go. But again, the powder coating on this end bell, that was done by our friend Craig Dusing. Here's the end bell for the other motor.
Did you
used to use a panel style fan that's typical in the industry. This is a baffle fan. And the difference is the panel fan just had the panels coming up on it. The baffle here allows it to move much greater air, about 50% more air than the standard panel fans. Those have yet to be machined. All of our 9-inch motors use the same fan. So you'll see lots of these around here because we're building a lot of 9-inch motors, both the impulse motor and the Warp 9 motor and the OEM 9-inch motors that you've seen. They all use the same fan casting. Looks like you're making my armature shafts.
Done over there.
Okay. You got one done? Okay. This is a finished one. Oh, almost finished.
Just got to go through the keys and stuff.
It's got to get the keyway cut in it, exactly. Yeah. There'll be a keyway cut in here that I mentioned to you earlier that will hold the lamination stack in place. That's one of the things we don't want everybody to know that we do, but it's an extra step that most people aren't willing to do. And here you can see the diameter of the raw stock, 2 1/4 inch raw stock, inch and 5/8 raw stock.
The other ones, the bigger ones that you have are 2 1/4.
Okay. Per shaft?
I'd say about 30, 35 minutes.
35 minutes on the CNC.
Yeah, 35 minutes to
Sawing them all the way through, stopping them.
So they're all saw over here. And you might want to get a shot of this stock. There's actually bigger stock over there. You see the banded stock about the diameter that we use. So they bring it in here, they cut all of them to length. So, you know, do they make everything here? Well, you know, obviously the steel comes from a foundry, but they cut it into lengths, these bar lengths. They get in the raw bars, cut it to length, and then machine it from there.
Warfield's been remanufacturing and repairing DC motors since 1974. They stock a huge number of forklift motors so that they can reference them for the remanufacturing process when they get a customer's order in. And they also manufacture brand new electric motors for special applications such as the electric vehicle industry, where they get specific design requests from companies like NetGain, who design the motors for their electric vehicle customers.